Hi guys, welcome to the lesson of partial differential equations. So in last class we discussed Cauchy characteristic method for the first order nonlinear partial differential equations and we solved a question. So now we'll take another question. So in order to consolidate concepts, so let's say that we are given with an equation that is pq minus q is equals to z times p, and the initial conditions are given as 1 comma ln s is equals to 1 minus s. So now the we are familiar with the procedure that we are given with some characteristic equations. uh, Now, first of all, let's say that f is equals to pq minus q minus z times p. So now the first characteristic curve is dx over dt is equals to fp. That is the partial derivative with respect to p. So this implies that dawa f over dawa p is equals to q minus z. So the first characteristic curve is dx over dt that is equals to q minus z. But we can see that this is not solvable as the function on right hand side is q and z. So now we have to take the other curve that is dy over dt that is equals to fq, and we know that the partial derivative of q will be p minus 1. So dy over dt is equals to p minus 1. And again, this is unsolvable because of the function of p on the right hand side. So we will name as equation number 2. And we will see further that we can get an equation that is solvable. So again, dp over dt is equals to negative fx plus p times fz. That will be equals to negative fx will be 0 because there is no function of x, plus p times fz is equals to negative p. So dp over dt is equals to p squared. Now we can see that this equation is solvable. So we can solve this equation and we can find p. So we will solve this equation for p, and this is a variable separable equation. So we will separate the variables and we will integrate. So we will get negative 1 over p on the left hand side and then c plus c1 plus t on the right hand side. So now we can write it as p is equals to 1 over c1 minus t. This is the first solution. So we found p in terms of t, and now we'll proceed further. The other equation is dq over dt is equals to negative fy plus q times fz. So again, there is no function of y, so fy will be 0, and it will be, we will left with q times negative p. So this will be equals to pq. So dq over dt is equals to pq. So we already found p in the above equation, so we can plug the value of t in terms of p in terms of t in this equation. So let's do that and solve for q. So dq over dt is equals to p, and now I will substitute the value of p in the equation. The value of p is 1 over c1 minus t multiplied by q. Now this is a separable variable equation, so dq over q is equals to dt over c1 minus t. So now this is integratable, so we'll integrate this equation. So this will be ln q is equals to negative ln c1 minus t plus ln c2. So I can write this as q is equals to c2 over c1 minus t using the properties of logarithm. So now we found q as well. So I will call this as equation A, and we can call this equation, that is P, as equation B. So now we have to solve for y, x, and z as well. So still, if we see in the problem, and the characteristic curve of dx over dt is q minus z, so we need to find z here, and for this dy over dt is equals to p minus 1. So we already found p, so I can replace the value of p. So dy over dt is equals to p minus 1. Let's solve this curve first. Dy is equal over dt is equals to p minus 1, where p is equals to 1 over c1 minus t. So I will plug this value. So I will get an equation like this: c1 minus t minus 1. Now it's obvious from this equation that we can solve it by shifting dt onto right hand side, because this is the function of only t on the right hand side. So it will be like this. Now we can integrate this function, and by integrating this function, what we will get is y is equals to negative ln c1 minus t minus t plus c3. So we already use c1 and c2, so we will use c3 in this equation. So now we got three equations, that is p, q, and y. Now we'll solve for z and x. So x is still not solvable because of this z. So we have to find z first in terms of t. So to find z, you look at the problem. In the question, function implies that pq minus q is equals to z times p. So I can write it as z is equals to pq minus q divided by p. And these values of p and q we already found, so we'll just replace these values. So it's the value of p is 1 over c1 minus t multiplied by the value of q is c2 over c1 minus t minus, then the value of q is again c2 over c1 minus t. And we can divide this equation by p. So p is again 1 over c1 minus t. So now we can see that we can take 1 over c1 minus t common from the numerator. So we will take it out. We will left with c2 over c1 minus t and minus 1 here. Sorry, this is not minus 1. It's minus 2. In fact, it's minus 2. Here's c2, sorry. It's minus c2. So now we can see that 1 over c1 minus t, this will cancel out, and we will left with z is equals to c2 over c1 minus t minus c2. So we got an equation in terms of t for z, and now we will put this z in the above equation, that is dx over dt is equals to q minus z. So we will replace dx over dt is equals to p minus z, or it's q minus z. In fact, yes, it's q minus z. So q is c2 over c1 minus t, and then z is equals to again negative c2 over c1 minus t, and this will be plus c2. So this will cancel out, and dx is equals to c2 times dt. Now this equation is solvable, and we will solve it. So we will get x is equals to c2 times t plus c4. So we already use c1, c2, and c3, so we will use c4 here. Now the next step is to apply the initial conditions. So initial conditions, we are We have now we have 5 equations, and we are only given with 3 initial conditions. The first condition is x of s comma 0 is equals to 1. The second condition is y of s comma 0 is equals to ln s, and the third condition is z of s comma 0 is equals to 1 minus s. But we need to find other two conditions, that is for p and q. Let's say the condition for p is p of s comma 0 is equals to h of s, and the condition of q of s comma 0 is k of s. So now we will solve it using some given equations. We know that h of s times f prime of s plus k of s times g prime of s is equals to capital G prime of s, where this f of s is just the condition for x, that is equals to 1, and g of s is the condition for y, that is ln s, and g of s is equals to 1 minus s. So now we can use this condition, and now h times, or the derivative of 1 will be 0, plus k times the derivative of ln s will be 1 over s, and the derivative of 1 minus s will be negative 1. So k is equals to negative s. Now this is one of the condition we need to solve this equation. And the second condition, we can make it from the question, where question says that pq minus q minus zp is equals to 0. So we can write h in place of p and k in place of q, minus k minus z is 1 minus s in the condition, and p will be h. So now we already found k as negative s, negative h, and positive hs is equals to 0. So this hs and hs will cancel out, and we will left with h is equals to s. So now it's pretty easy to solve these 5 equations, solve equations for the constants c1, c2, c3, and c4. So we will plug the initial condition. So now the initial condition of s comma 0 is found to be s, and the condition for q of s comma 0 is found to be negative s. And we know that p is equals to 1 over c1 minus t. So this implies that s is equals to 1 over c1 minus 0, because 0 here t is equals to 0 because it's initial condition, initial value problem. So by reciprocating, I will find c1, so it will be 1 over s. Now for c2, I will use q is equals to c2 over c1 minus t. This implies that the condition for q is negative s, and c2 I have to find, c1 I already found as 1 over s, and then minus 0. So c2 is equals to negative s times 1 over s. This will be equals to negative 1. So you see that c2 is equals to negative 1. So now we can find c3 and c4 by using the equations of z, y, and x. So let's now we have c2, so we can find c4 from this equation. So the condition for x is x of s comma 0 is equals to 1. So I can write 1 is equals to c2 times 0 plus c4. This implies that c4 is equals to 1. And now I will find c3. Now we have to work for c3, because c3 is still not in the party, so we have to find c3. So for c3, I will use this equation, y is equals to negative ln c1 minus ct plus minus t plus c3. So let's do that. So y is equals to negative ln c1 minus t plus c3. So the condition of ys comma 0 is equals to ln s. So I will write here ln s is equals to negative ln C1. What is C1? C1 is found to be 1 over s, so I will write here 1 over s minus 0 plus C3. So now we can see that C3 is equals to ln s plus ln 1 over s, and this is equals to ln s times 1 over s. S and s will cancel out, so C3 will be equals to 0 because ln 1 is 0. So now if found all constants, now we'll plug these constants into the equation. So x is equals to C2t plus C4. So C2 is negative 1, so it will be negative t plus C4, and C4 is found to be where is C4? C4 is 1, so it will be negative t plus 1. We will box this. Now we will check for y. So y is equals to negative ln c1. C1 is C1 minus t. So C1 is 1 over s. So it will be 1 over s minus t. Again, here it's minus t, and C3 is 0. So this is equation number 2. Let's say this is equation number 1, and this is equation number 2. Now we will look for z. Our z is equals to C2 over C1 minus t minus C2. So we will apply the values. C2 is equals to negative 1. C2 is equals to negative 1 over C1 minus t, that is this term, and then minus C2, that is C1, so it will be plus 1. We'll check again for z. Z is equals to, yes, minus C2, and C2 is equals to negative 1. So this is the third equation. Now we have to use these three equations to solve for z in terms of x and y. So we need a function of z in terms of x, y. That will be our Cartesian form, and that is our goal, to find the Cartesian form. So now I can see that if I want to if in the equation number 2, I can see that I can do some manipulation. 2 implies that y is equals to ln 1 over s minus t to the power negative 1, because I shift this power of minus to the shift this negative sign to the power of 1 over s minus t. I can do that using the property of log, and minus t will remain here. So I can write it as y is equals to 1 over s minus t, and this is the function of log, it's minus t. And from equation of z, we can see that negative 1 over s minus t is equals to z. Plus 1 is equal to z. So this implies that I can write 1 over s minus t is equals to 1 minus z. So I will replace this by 1 minus z. So y will be equals to ln 1 minus z minus t. So y is equals to ln 1 minus z minus t. Now half part is done. So now I have to remove this t from here. So for this t, I will use the equation of x, that is t will be equals to 1 minus x. So I can write 1 minus x in place of t. So I will write 1 minus x in place of t. So this will be y is equals to ln 1 minus z minus 1 plus x. I will shift this onto right hand side because I need a function of z in terms of x and y. So this will be y plus 1 minus x is equals to ln 1 minus z. So to remove this logarithm, I will use the exponential in the base. So I will be left with y plus 1 minus x here, and this ln will cancel out, and here it will be 1 minus z. So now z will be equals to 1 minus e to the power y minus x plus 1. And this is the final answer, and this is the Cartesian form. That is z in terms of x and y. And we our goal was, and our objective was also this, to find z in terms of x and y. So this is very important question. So hope you guys will like this question and you will learn from this question. Thank you for watching the lesson.